Okay, in the last video, this example got cut off. Here we're asked to come up with a function rule that models this growth. And so I had said that if this first little dot here, if this is figure 1, and then this is figure 2 with the 2 dots, and figure 3, and this is figure 4, and so on, if you notice, in each figure, it's doubling. So if I were to create a table, which this is sometimes a little bit easier to see, if we got figure 1, then figure 2, figure 3, figure 4, and so on. If we make a table, it might be easier to see what's happening here. So figure 1 has one little dot, so I say, yep, it's got 1 here. Figure 2 right here had 2 little dots, or 2 circles, and in figure 3 it grew to 4. And then in figure 4, we can see that it grew to 8. So I'm just filling in my table here. Now you can easily see that each time with each figure, we are doubling, which tells us that, that's a geometric sequence. With a geometric sequence, you are going to have an exponential function. So y equals a times b to the power of x. So the multiplier here is easy to see. I'm multiplying by 2 every single time. So that's my multiplier. But the number that's in front, the a value, that's the y-intercept. So we kind of got to go back here and figure out when x is 0, what is y? So remember, the pattern is to double. So think what would have to be here where if I doubled it, I don't know why I write times 3, times 2, where if I doubled it, I get 1. Well, that would be half. And even if you went backward and you divided by 2, you would get back to that half. So now if I take half and I double it, I get 1. I double it, I get 2. I double it, I get 4. So right here, this is my y-intercept, 1/2. So there's my 1/2 right there. That's the function rule for a growth pattern that's geometric, like the one that you see here. Okay. So now let's take a look at summarizing what's going on. What is the difference between when it tells you x is 0, 1, 2, 3, and when it tells you x is 1, 2, 3, 4 when it comes to writing a function rule? What do we have to be thinking about? What's the difference? Well, when x is 1, 2, 3, you're given the 0 term. And when you're given the 0 term, that's the y-intercept. And so you have that part of your function rule, whether it's linear or it's exponential, you know the y-intercept is that first term in the sequence. But when it tells you that the sequence was made when x equals 1, 2, 3, 4, the difference there is that you have to actually go back and find the 0 term in order for you to be able to get the y-intercept for your function rule. So it's important that you take a look at how the function was made. Was it made when x equals 0, 1, 2, 3, and the y-intercept is given to you? Or is it made when x is 1, 2, 3, 4, and you got to go back to find the 0? All right, so there we got our summarizing with this lesson. Thank you so much for joining me.